This video is going to demonstrate how to use JASP in order to create summaries with descriptive statistics and to visualize your data with different types of graphs. This video corresponds to material covered in Chapter 3 of our text, Applied Data Analysis in Psychology, Exploring Diversity with Statistics. The data that we're going to use for this exercise explores some of the research that has highlighted barriers for women who want to engage in STEM careers, with STEM being science, technology, engineering, and mathematics. Research has considered how work environment features might affect women in STEM and their comfort or desire to work in these fields. In the study that we're going to use, this is an experiment where women who were engineering students performed a problem-solving task with a team, and those teams had varied ratios of males to females. So one group was primarily female, one was minority female, and one was even ratios. The data gathered included how they did on the problem-solving task, how challenged versus threatened they felt, and they included some measures of implicit and explicit attitudes around sex stereotypes in engineering. We're going to use a few of their variables to demonstrate basic descriptive analyses and graphing. The specific JASP skills we're going to cover in this walkthrough include how to compute descriptive statistics. That includes frequency tables, measures of central tendency and variability, and some measures to show us if our data is roughly normally distributed. We'll also create visuals that will include histograms, bar charts, pie charts, box plots, and scatter plots. I've pulled up here the JASP file that we're going to use for this particular study. You've got a version of this provided to you that is directly a JASP file. There's also a CSV version if you prefer to use a CSV version and upload it into JASP. If that's what you're doing, and when you open up JASP, you can use these three bars here to click Open in Computer and browse to find that CSV file on your computer, or browse to find the JASP file if you haven't just opened it directly from a file folder. We're going to focus on computing some basic descriptive statistics. We're going to start by clicking the Descriptives menu. This is how we'll access both our descriptives and our plots. A nice thing about JASP is that everything is going to be available in one window. Your results are going to automatically generate over on the right-hand side of your screen as you adjust options in the menu on the left-hand side. To begin my calculations, I can just start moving over the variables that I want to use. For instance, if we want to know about the age of our sample, I'm going to take this age variable here, and I'm going to click this little arrow to move it over into my variables menu. And you'll see that automatically my results table starts updating, where I have the valid number of cases, the number of missing data, and my mean, standard deviation, minimum, and maximum. I'm going to add over a couple more variables for us to look at, including the threat by challenge score and the stereotype IAT score. Notice I double-clicked those to move them over, or you can simply click them and use the arrow again, like the first time. To go and find the options that we can use to request more information, I'm going to click the Statistics drop-down menu. This is going to let me select what statistics I want displayed in my table, because right now it's just the very basic statistics for the minimum, maximum, mean, and standard deviation. So I can select for central tendency all of the key measures of central tendency you learned about in Chapter 3. That's the mean, median, and the mode. For measures of dispersion, I can request quartiles, which shows the different quarters of my data. If you divide it up into 4 equal parts, where does the 25th percentile start? Where does the middle or the 50th percentile start? And where does the 75th percentile start? I could also request IQR if I just wanted a summary of the distance between those two interquartiles. The same goes for the range. The range will tell me the distance covered between the minimum and the maximum value. We learn about variance, but typically we just focus on interpreting standard deviation because it is in the regular units of your variable rather than being in squared units, which is what variance is. Under distribution, we can click skewness and kurtosis so that we can see some numerical values that will tell us whether or not our variables differ too much from a normal distribution. Clicking my arrow over, I can display my results in my full screen to make it a little bit easier to see. You'll see that the layout of this output is to have the variables named in the columns, and each row represents a different statistic reported. We'll see, for instance, as we walk through age, that there were 116 valid cases for individuals with missing data. We have 18.97 as our average age, while the median is 19, and the mode, or the most common result, is 18. We can see our standard deviation of 1.43, meaning that on average, most people were within 1.42 years of that average age of 18.97. The IQR tells us the difference between the 25th and 75th percentile, which if we look down here, we see our 25th percentile started at 18 years old, and our 75th started at 19 years old, so that difference between the two is 1. Related to this, the range shows the distance between our minimum and our maximum value. So our minimum value was 17 for age, our maximum value was 27. So the distance between those two is 10. We also have values for skewness and kurtosis, and those will tell us about deviations from a normal distribution. For instance, with age, this skewness value goes above the plus or minus 2 cutoff, which we would typically want to see to consider data roughly normal. This means that our data was somewhat skewed by higher values in the sample, though most people were around the same point. The same goes with kurtosis. High kurtosis or positive kurtosis means our distribution is leptokurtic and that most people are responding all in the same place. Our distribution is tightly clustered together, which we'll see when we create some visuals in a little bit. For other variables, there's a little bit of a higher kurtosis value for the threat by challenge appraisal, meaning that scores tended to be clustered a little bit closer together, but the scores for skewness and kurtosis for that stereotype IAT score are about the same, so there's no issues there. Another thing we sometimes want to know is just the number and count, and so a frequency table can tell us the number of times a particular response occurred. If we check that, it'll provide that for any nominal or ordinal variables we have. In this survey, we have age labeled as an ordinal variable, and so we can see the frequency counts for age. For instance, 2 people in our sample were 17, 51 people were 18, and 37 people were 19, and so on. We can see our valid percent and our cumulative percent. This is a slightly different example than your textbooks. I've made this to have some missing data here. If there was no missing data, percent and valid would look exactly the same. In this case, we do have 4 missing responses, and so the valid percent would be the percentage when calculated based on the number of people who gave a response. The percent would be calculated based on people overall. For instance, 3% had a missing response, and so this looks a little bit different when we don't account for those missing values and just calculate our percentages based on the 116 that did provide a response. The cumulative percent shows how many people are at or below a certain value. And so, for instance, with 20, the age of 20, 89.65% were 20 or younger. And so it's just adding up as you go. 1% were 17, 45% were 18 or 17, 77% were 19, 18, or 17, and so it's just accumulating or adding those percentages together as you move down the table. Another useful feature that we might want to see is our output split by another variable. So in this example, we know that there were 3 different study conditions, so perhaps we want to look at our different variables split by conditions. So this works well with categorical variables, and we just click the little arrow down here next to the split box. And what's going to happen is now our output all shows up split by this categorical variable. So we see the age, for instance, for our experimental group that had mostly females. We see the age for our experimental group that had females as the minority. And we see the same descriptive information for our group that had equal males and females. So rather than seeing all of these groups combined, we're separating it out so we can look at these scores uniquely for each of the 3 groups. And this can be helpful with some of our key variables. For instance, the threat by challenge score of how they felt threatened versus challenged in performing their task, you can see that in the female majority group, that mean score is a little bit higher or a little bit lower than the female minority group. So they felt a little bit more threatened versus challenged when they were the minority in the group versus when they were the majority or in an equal male-female group. So this can be really helpful when you're wanting to explore your groups, and we'll use this when we test some assumptions of analyses that have different groups being compared. The same can work for our frequency tables, where you see we have the frequency counts for each age option for the female majority group, the female minority group, and the equal male-female group. Next, we'll add some plots to the mix so we can see how we can visualize data. I'm going to take condition and move it back so that I'm just focusing on the simpler output for our 3 focal variables of age, threat by challenge scores, and stereotype IAT scores. And I'm going to scroll down and make this option active for plots. We'll look at several different types of plots. We'll request a box plot, which is a good display of the dispersion of the data. It shows the range of responses in the interquartile range. It can also show us if there are some outliers in our data. We'll request a scatter plot, and to keep it a little bit simpler looking, I'm going to click none for these options for extra graphs displayed on either side. And I'm going to click linear for the regression line. We'll get into regression a lot more in a later chapter, but this is a typical format for a scatter plot. Lastly, going back up in the menu a little bit, I'll request distribution plots, and these will produce histograms for our variables. If we had categorical variables in our list, that would produce a bar chart, but since it is continuous variables, this is technically a histogram. If we again go back to our output and scroll down to see the new visuals that are added, we can see our distribution plot showing up, and that age variable does show a positive skew where we've got most of the data on the low end and the tail going to the higher scores. We can see that our threat by challenge scores were also a little bit on the skewed side, but to a lesser degree than age. And then we see our stereotype threat score for the IAT is actually fairly normally distributed. That looks closer to a normal distribution than our other variables. For our box plots, we can see that age had several different outliers. The typical range, or the range of our variables, was around 18 to 20 years old, and it was uncommon to see people that were a little bit older, maybe in their mid to late 20s, so those would be flagged as outliers in our particular plot here. For our threat by challenge scores, we can again see the range of values from a little above 0 to around 2, with a few outliers with scores closer to 3, meaning they felt very threatened versus challenged. The stereotype IAT score box plot is an example of one that doesn't have outliers. We can just see the range from the minimum to the maximum of negative 0.5 to around 1, and we see that interquartile, or that middle 50%, is ranging more from about 0 to 0.5, and this black line in the middle actually signifies our median value, or the 50th percentile. These scatter plots can show if there's a relationship between variables. For instance, here we see maybe a slight pattern of relationships between those who are older feeling less threatened, but that relationship isn't super clear. We'll learn how to analyze those when we get to correlation and regression. And we can see patterns here for age related to stereotype scores. And we see here that feeling more threatened was associated with higher perceptions of stereotypes for STEM fields. If we wanted to, we could also again split these plots by condition if we just wanted to see visually what do these look like and how do they differ. I could move condition back into that split box for my visuals as well, and this is going to give us a good bit more information. If we go to our output, now we're going to see that we have a histogram provided for our variables for each group. This is the female majority group, the female minority group, and the equal male or female group for age. And then we have the same thing for the threat by challenge for our 3 conditions. So we have 3 distribution plots, or 3 histograms for threat by challenge, 1 for each condition. And we see the same thing for IAT scores. We have our plots for the female majority and female minority group, and for the equal male-female group. The box plots can be helpful too because we can spot if there are outliers in one group and not another. For instance, with age, we see that our older participants were primarily in the female majority group, and we just had some lower outliers in our female minority in the equal male-female group. For our threat by challenge scores, we can see if there was similar degrees of variability between our three groups. They tend to cover similar spaces with a few outliers in each group. And lastly, you can see that our stereotype IAT scores were fairly similar in each group. You'll notice the range is a little bit different for this equal male-female group than it is for the others, but overall, there's nothing that is hugely different in the variability or spread of these groups. Again, these can be helpful when we're checking some assumptions later on. In some of our analyses, we'll want to see distributions or ranges of values that are relatively similar for our different groups. And as you're working with JASP, you can alter these and make them a little bit bigger or smaller so that they'll adjust and the visuals will be a little bit more clear, so you can adjust the sizing of those. You can also click these drop down arrows to copy the image if you want to copy it and paste it into your homework or copy and paste it into a presentation. You can do that there or take a screenshot. That's the primary visuals that we're going to talk about for now. We'll explore some more as we get into different analyses, and we'll explore how to make some graphics that are a little bit easier to follow or a little bit easier to format when we get into Excel.